For this video, let's try to evaluate the given function along a straight line between 0, 1 to 2, 5. This time, our path is a straight line path. Hence, in solving for this real line integral, we're going to use the parameterization for the straight line path. Now, let's not forget that, of course, the real line integral of your p of xy dx plus q of your xy dy along your path C is just equal to the integral of your p of your x of t and then y of t, by the way it has a bracket here, times the first derivative of your x of t plus q of your x of t and y of t times the derivative of your y of t dt from a to b. In order for us to solve this, we need to really complete all the details here, specifically for the parameterization of our x and y. Let's not forget that the first item that we can identify in our given would be the functions p and q of xy. Your p is actually the function to be multiplied with dx. Hence, you will have here 3x plus y. As for your q, this is that function. You will have 2y minus x. We need that later on because as soon as you identify the parameters for x of t and y of t, you will be substituting that in our functions respectively. Speaking of parameterization, for our x of t and y of t, we need to really look at the process of parameterization on the straight line path. And let's not forget that for a straight line path, your x of t is actually x sub 1 plus 2t times the difference of your x sub 2 and x sub 1. Similarly, for your y sub t is y sub 1 plus t times y sub 2 minus y sub 1. Let me move that down here. And let's try to identify the x sub 1, x sub 2, y sub 1, and y sub 2. For your point here identified, of course, this is your x sub 1, this is your x sub 2, y sub 1, this is your x sub 2, and this is your y sub 2. So for your x sub 1 was 0 plus t times 2 minus 0, which will give us 2t because this is 0 here. Okay? As for your y, this 1 plus you have the product of t of 5 minus 1, which gives us 1 plus 4t. These are now the parameters that we can substitute for our given two functions here needed for our integral. But first, let's complete the other requirements, the first derivatives. So for our x of t, which is 2t, its first derivative is 2. And as for our y of t is 1 plus 4t. Its first derivative is 0 plus 4. Okay, with respect to t, that's actually equal to 4 itself. Okay, now we are done with the derivatives. We are to substitute the x of t and y of t in our two functions. But first, let's try to determine the correct a and b. Okay, we know that for our a and b, as discussed previously, the most convenient values for a and b for a straight line path is actually 0 to 1. You can use other values, but as suggested, this is the most convenient value because this is the simplest transformation as t starts from 0 to your 1, which are corresponding to your two identified points as endpoints of your path. Now, we have that. The next thing here is for our p of x of t and y of t. Originally, our p of xy is identified as 3x plus y. So, if you're asked to p of x of t and y of t, simply change the x into x of t and y to y of t. This is a 3 of x of t plus y of t. Your x of t is actually 2t here. So that's a 3 times 2t plus your y of t is 1 plus 4t. Combining them, you will have here 6t plus 1 plus 4t. So your p is just 10t plus 1. Okay? So your function earlier of x and y now becomes a function of t, no longer containing x's and y's. Similarly, for your q of xy, originally 2y minus x. if we're going to have q of x of t and y of t, so basically you need to have 2 of y of t minus your x of t. Your y of t is again this one here, 1 plus 4t. So 2 times 1 plus 4t minus your x of t, which is 2t. Similarly, you will now have functions of t. So you have here 2 plus 8t minus 2t. So basically, you will have here 2 plus 6t for your q. Okay, now, we have all of this. The next thing is to finalize our integral form and hopefully simplify them later on. So this is actually equivalent to the integral from a to b is actually identified here, 0 to 1. So 0 to 1 of your, what was the first? Your p of xt and yt times the derivative of your xt. So your p of, what is this one here? 10. Let me write here parentheses because this would be under the same expression. So again, bracket here, you have 10t plus 1 times the derivative of your x of t, which is 2, plus your q is 2 plus 6t times the derivative of your yt is 4 with respect to dt here. Now, let's do this step by step. So combining, or multiplying the terms inside, you will have 20 plus 2, 20t plus 2 plus 8 plus 24t dt using the what do you call this, linearity property. Sorry for that. You will have here 20 0 to 1 of your t dt. We can still combine them, my bad. Let's try to combine them first. Okay, 0 to 1, 20 plus 24 is of course 44 t plus 10 of your dt. Okay, so it's now even smaller. Using the linearity property, 44 from 0 to 1 of your t dt, and you have your plus 10 of the integral from 0 to 1 of dt. We know that the integral of t dt is t squared over 2, and the integral of dt is just t itself. So we will have here 44 times t squared over 2 from 0 to 1 plus 10 times t from 0 to 1. You can of course simplify this. We'll have here 22. So this is equal now. Take note of the substitution. 22 times 1 squared minus 22 times 0 squared plus 10 times 1 minus 10 times 0. This is 0. That's 0. You will have here 22 times 1 squared is obviously 22 plus 10. You will have here the answer of 32. This is now the answer to the question. This is the integral of your functions here along a straight line between 0, 1 to 2, 5, following the correct parameterization and properties of integrals and these items needed for the answer. Okay, so the answer is 32 for this item. Thank you very much for watching.